Hey folks, how's it going? This is Mr. Moray coming to you with a Do Know activity for Monday, March 30th, 2020. Okay, so in this Do Now, we're going to continue to build upon what we've been doing with regard to bearings. So originally, we focused on setting up a triangle and then maybe using the law of sines, the law of cosines, or maybe SOHCAHTOA, if we got lucky, to figure out the distance between the ending point and the point where the ship or the yacht or the boat or whatever took off. Then what we did is we added in the problem of find the bearing from the original point, okay? And so in this video, Do Now, we're going to try to find the bearing and the distance to see where we're at, okay? So this is the situation. Big Yachty's luxury yacht set sail again from Port Oprah at 5 p.m., heading due west at 25 knots. At 10 p.m., it changes course to south 30 degrees east. You could also say changes bearing. Find the ship's bearing and distance from Port Oprah when the yacht arrives home at midnight. Okay, so what I want you to do, again, think about the process that we've done in class. We need to read and understand the problem. We need to highlight the important information. We need to draw a picture. We need to use the picture to make the triangle. And then we need to apply the relevant law, the trigonometry law. So whether that be SOHCAHTOA, law of sines, or law of cosines. All right, so take a minute, pause the video, try to solve the problem. All right, and then when you're ready, unpause, and I'll show you what I got. All right, so here we go. So the things we got to think about are, let's see if we can highlight some important information. So we're starting off at 5 p.m. We're going to be heading due west at 25 knots. And remember, knots means essentially miles per hour, except like it's nautical miles. Like when you're on a ship or like a boat saying, oh, we're going 25 knots, meaning we're going to cover 25 miles across the water in 1 hour, okay? As opposed to like the road. Okay, at 10 p.m., so that's good to know, 5 hours later, we're going to change course to this new bearing, south 30 east. And we need to find the bearing and the distance. So I'll highlight that in red so I make sure that we find the bearing and the distance. And we need to know when it arrives home at midnight. Okay, so what I'm going to do is I'm now going to use this to draw a diagram. So first of all, if we look at our, like a compass here, right? Okay, this would be due west, directly west. Okay, the other thing we might want to look at, if we look at north, south, east, west, is south 30 east. So I look to the south and I turn 30 degrees to the east. So I'm 30 degrees east of south. Okay, two things worth noting. Now, how do we translate this to a picture? So I'm going to start here. This is my port, Port St. Oprah, or Port Oprah, and I'm now going to go due west. I'm going to use a line tool to help me with this. Forgive this menu right here. I just want to make sure I stick to the same color. So here we go. We're going to be heading west, and let me just adjust that so it's a nice flat line. Come on now. Perfect. All right, so here's me heading due west, and maybe I'll extend this a little bit because we're going to be going for quite some time. All right, then there's going to be a part where we're going to change course, okay? And so when we reach, we get this a new dot. Okay, when we reach this point right here, it's like we've got a brand new north, south, east, west, right? Remember, this is east. We're now going to, let me grab my line. Hopefully I don't default back to red. It looks like I will. It's okay. This is the new bearing. Okay, and so what I need to know is, let's do this in purple, and we'll make this a dotted line. The purple line represents the distance, okay, between the home location and the original port where we started from. Okay, and so I'll go ahead and I will use a purple dot right here. So I need the distance and the bearing from Port Oprah. Okay, so what I need to know is, if I start here, what's the bearing from Port Oprah that I need to know? Okay, this is my bearing right here. And there's a couple different ways we could talk about this. This problem is somewhat made a little bit easier, and I don't want to insult anyone by saying easier, by the fact that we're starting due west. That is going to help me, because sometimes when your bearing isn't due one direction, you have to like get an angle and then add two angles together. And if you don't know what I mean, I recommend you I suggest that you check out one of my previous videos. Okay, so here's what we've got. We know that we're going to be going 25 knots, and this is the first leg of the journey. So we're going 5 hours. So at 25 nautical miles per hour, we're going to have gone 125 nautical miles, because we're going to be traveling for 5 hours. Okay, then the other thing I know, first of all, let me label this. This is 30 degrees, this angle here. Then I also know that between this point and this point we'll have gone 2 hours. So this is not very drawn to scale, but we know that this is 50 nautical miles, because you're going to travel 2 hours at 50 nautical miles per hour. Now again, we are helped by the fact that this is due west. So what that tells me is that it's great. I'm going to be able to actually calculate the angle across from the side I want to find pretty easily, because I know that these have to add up to 90 degrees. And again, the due west saves me a lot of pain. So this is going to be a 60-degree angle right here. Okay. And so I do know that. The other thing is, can I figure out any other angles? I don't know. I mean, I've got the angle across. I've got the two other sides. So I'm going to say at this point, let's go ahead and try to find this. Now, I don't know that anything is 90 degrees. For example, so what I'm getting at here is that, remember, if I set up this like little invisible north-south line, right, we know that this and this are parallel. We can see they're parallel. So this is a transversal, which would make this a 30-degree angle. But here's the thing. I can't figure these out, because I would need to know this piece, and then we know this is going to add up to 90. I don't really have enough information that I can think of, so I'm going to go ahead and I'm just going to go for the law of cosines, because I have what I need. Okay, so what I know, and we're going to call this the distance, is that the distance squared, the purple, I'll try to color code this, is equal to 60 squared plus 125 squared minus 2 times 60 times 125, rather not 60, I'm sorry. 60 should be 50. I'm getting confused because we want the side, not the angle. 50, 50, and then we're going to add in the cosine of 60 degrees. And the good news is, if you know about cosine, you know 60 is an important one, and it's 0.5. So it's going to make our numbers come out pretty nice. So let's figure this out. So I've got, remember, you just plug this right into your calculator. Let's see if my calculator is going to be nice. It's going to let me use the keyboard shortcuts this time. So I've got 50 squared plus 125 squared minus 2 times 50 times 125 times the cosine of 60 degrees. Okay? So I get the distance squared. Let me put this in, and it's going to be a whole number. So whenever you have a whole number, obviously you want to capture all the digits. So 11875. This is not going to likely have be a perfect square. If it is, that's awesome, but very unlikely. Okay, so what I'm going to do is I'm going to put 3 decimal places. So the distance is we should say approximately 108.972. So when we report the distance, we are going to report the distance as 109, because you round to the nearest tenth. The 7 will spill over, that will spill over. So we'll talk about that in a second. Remember, when you report it, we're going to report with 1 decimal place. when you use it for a calculation, which we're going to do, you need to report 2 decimal places. So what we need to do now is I want the bearing from Port Oprah. So what I need to do is I need to figure out this angle right here. Okay? And the only way I know how to do that off the bat is with the law of cosines. So what I know, and remember 50 is the opposite from the angle, so I'm going to do that 50 squared, and I'll just do this in different colors again. So it's equal to 125 squared, and then remember, because it's an intermediate calculation, I do need to capture all 3 digits because we don't want any rounding errors. Believe me, if you haven't seen it yet, you'll know that 3 decimal places significantly reduces rounding errors. Okay, because it's not going to give you a perfect answer either way, but it will give you a much better answer if you round any intermediate work to 3 decimal places. Okay, and then I need the cosine of we don't know. That's what we need to figure out. Okay, but remember, we know based on the law, and if you don't have the note sheet at this point, yikes, you really want to have that because we talked about how to derive these laws for the angles. So remember, you'd basically be getting the cosine alone. So 50 squared minus 125 squared minus 108.972 squared over negative 2 times 125 times 108.972. Do not copy the answer. I don't use ants at this point because because then it's going to copy in all the digits. I don't want to do that right now. Okay, then remember, again, I'm going to continue to kind of sorry if I'm beating a dead horse here, but I'm going to continue to insist that you please calculate the numerator and denominator separately so that you 100% avoid any PEMDAS, unintended PEMDAS errors that the calculator will put on you. So I've got 50 squared minus 125 squared. I'm going to double check. Nice. I'm going to get, oh, nice. This is a pretty cool numerator. So I'm going to get, for my numerator, I'm going to get negative 24,999. And I'm going to include all of the digits, 89678, because I want as little rounding error as possible. And it's not a big deal to throw on a couple more decimal places. Again, if you were to round to 3, that's not something that I would mark you down for. I'm not going to get that picky because I've said in the past round to 3, so that's not a big deal. If you just wrote 25,000, that would be a problem because that's a significant amount of rounding, and hopefully at this point we know better than that. Okay, now this is a situation where you don't need any decimals, and that's because there literally are not any decimals in the answer. I'm not sure how we got such a perfect answer, though. That's crazy. It went down to no decimal places at all. You would never think that based on how many decimal places were in the answer, but it looks like it's what we've got. So now what I need to do is remember that this is the cosine of the angle. So what I need now is that the angle is equivalent to the inverse cosine. And maybe I can just copy this. That's what I'm going to do. So I can save myself some writing. Boom. Copy that right in there. And now our goal is with the calculator, and this is why I say calculate the numerator and denominator separately, because now we'll do second cos, we'll do negative, make sure you get the right negative sign, 24999.896678 divided by, here you can get cute with it and go second and pull the answer from the previous problem or just type it in. And what we get is, I'm going to, again, I'll round to 3. Theta, the angle is approximately 23.413 units or degrees. Again, at this point, you should ensure, I don't know why it's not letting me do second mode, but you should ensure that your calculator's mode is set to degrees. It should be at this point. If you're using Google or Wolfram, just a quick thing, make sure that you look at what it's using, because I think by default, both those like to use radians instead. And remember, We haven't talked about radians yet, but what I've said is that radians and degrees are significantly different, so you cannot be using radians, okay? All right. So I know that this right here is about, let's say, 23.413 degrees, okay? So basically what's happening is I'm looking west, and so I'll say this is my bearing. So my distance, you have a lot of answers you could use here. So distance would be 109 nautical miles, and the bearing from the port. So if I'm standing in the port, I'm going to look out west, then I'm going to turn 23 degrees south. So what that means is I start, this is where it gets tricky. So I look to the west, and then I turn 23.4 degrees to the south. So it's 23.4 degrees south of west. There's other ways you could talk about it. You could say, let's see, if I added 90 to that, oh, now it wants to do this second nonsense. So if I add 90 to the answer, you could say 113 degrees west of north. I'm not saying right now that you need to stick to a particular format. I'm not saying now that you have to frame it all in terms of north. But if you really want to get cute with it, you could then subtract 360 degrees from this answer. And that would give, so that means that if I swing 240 degrees all the way around, I should get back to the same bearing. But I'm okay if you want to do this as well. Okay, so these are our two answers. Again, this was somewhat simplified by starting due in one direction, but that's okay. All right. So folks, hopefully you got this right and you understand how we did this. I know that this was a longer due now, but I wanted to hit on the ideas of distance and bearing together in one problem. So please continue the problems from the Bearings 2 worksheet. Make sure you check out the answers to the ones you've done so far. But keep it up. Keep the positivity flowing. Don't forget to love math. And remember, you can do it. All right. Thanks again for watching. Have a wonderful day, and I'll see you next time.